Hi everyone, we will be starting shortly. Before we begin, a few reminders for all our attendees. First, as this is a webinar-style Zoom, the attendees will not be allowed to turn on their microphones. However, please feel free to ask a question or chat your comments in the chat room. We will be having a Q&A session with our speakers after their presentations. Secondly, this virtual event is being recorded and will be shared with everyone after the event. We'll also be posting them on our Facebook, LinkedIn, YouTube, and website, philtunnel.com. And lastly, after the program, we'll be having a group picture, so please don't leave right away. Now, to start our program, it is my honor to introduce the new president of the Philippine Tunneling Society and the Director of Infrastructure for Arab Hong Kong and the Philippines, Mr. Mark Wallace.
Hi, welcome back everyone to the Philippine Tunneling Society. I need to apologize that we've been not online for a while, and as you probably know, I've now taken over from James Rickard as the president of the society, and I hope that I can get your support to share experiences and continue the forum on tunneling and underground works in the Philippines. So in doing that, we intend to continue monthly online meetings, and hopefully we can restart the face-to-face meetings in the near future as the pandemic eases. I'm sure that you've now seen the new newsletter. So we sent out a newsletter, news bites to all the members on the mailing list and so on, and we hope to be sending that out every month. But we need your news and project updates to help spread the word on the tunneling projects and opportunities in the Philippines. So we're going to continue doing that, and there'll be a new newsletter coming out very soon. So for today's presentation, we would all like to welcome our distinguished guests, Manila Water, together with the Novabala team and our construction management team from ARA. We also have online various guests from the JD Partners, CMC, First Balfour, Chunwo, and also many of the suppliers, subcontractors, and designers that have been involved in the project. Unfortunately, we don't have Bill Stewart here. So Bill was involved in the Novabala team with First Balfour on the NBAQ4, and sadly he passed away in September. And in the new newsletter, we will put an obituary in there, and he's really sadly missed. And he brought some great insight into the NBAQ4 project. So before we move on to today's presentations, I'd like to ask Malcolm Lorimer, our treasurer, to give a few announcements in terms of things that he's got to say about finances, etc. Malcolm?
Hi, Mark. Thank you very much. Thanks for that introduction. Good afternoon to all of our guests today, and thank you very much for your attendance. As Mark said, I'm the treasurer of the Philippine Tunneling Society, and what we're actually currently up to is we're just finalizing the annual accounts to prepare and present at the next annual general meeting, which will take place later in the year. What I'd also just like to mention is that, as Mark said, we're resuming our program of activities. What we did last month, perhaps even late August, was to send out some reminders for the many members who back in 2020, just before the pandemic struck, made a lot of very, very generous pledges to become different members in categories in the Philippine Tunneling Society. We have received quite a lot of the contributions, but there are still a number that remain outstanding. And first of all, I'd just like to say for those people who've recently just paid the contributions, thank you. And what we would like to do is ask anyone who's made a pledge, and we'll be contacting you guys by email, if it's possible to try to get those cleared in the next sort of 4 to 6 weeks. The reason that we're wanting to do that is we want to keep on offering various services to the community, and if we've got a reasonable balance of funding, that's going to allow us to make some proposals on the 2022 fee structures. So I just ask for anyone who's able to make those contributions, please do so. And a final reminder before I pass back is just to let you in the actual membership categories are a corporate sponsor, which is an organization which is costing 30,000 pesos per annum, a corporate member, which is 18,000 pesos per annum, and an individual member, which is 3,000. So thank you all very much in advance for the contributions, and we're looking forward to making some announcements on the 2022 fees and the accounts in the AGM that's coming up. Thank you, and I'll just hand back to Mark at that point.
All right, okay, thanks, Malcolm. So today we have two speakers. We have Alan Badu, who's Manila Water's project manager on NBAQ4, who really doesn't need any introduction, to be honest. You know, he's a legend in the water business. And we have Rod Scott, the project director for Novabala, who's got lots of experience in managing large, complex projects. And Alan will provide insight into the project, and Rod will present on the various tunneling and project progresses and milestones, and give you lots of nice photographs of what's been happening on site. So our first speaker, Sir Alan Badu, is a civil and sanitary engineer with over 40 years of experience in the water industry. He's got a master's in business administration and management. And as I said, he's been working in the water industry with MWSS from 1980s up till 1997. Then he went to Manila Water in 1997 up until now, and has over 40 years of experience in the water industry. So he's a master at the water business. So he's mostly been in the construction operations side of things and handled the wastewater expansion for MWSS. And in Manila Water, he's been had different roles as network manager, area business manager, and he also has worked overseas, leading the team in Manila Water's expansions in Ho Chi Minh in Vietnam. And two of his notable projects that he's handled in the past, Balara Treatment Plant 2 expansion and this NBAQ4 project. So, we look forward to Rod's presentation. And then the second speaker is Rod Scott. He has over 45 years of international construction experience, working in projects all over the world for Balfour Beatty companies. These range from highway projects, road projects in the UK, even up to desalination plants, power plants in Dubai, paper mills, and power plants in Indonesia, and rail projects in Malaysia. He's found a second home, the Philippines, so he loves it here, and he's been here since 1997. He's managed some pretty large power plants in the Philippines, providing up to 1.5 gigawatt of power in power plants in Batangas. And he's been also involved in various other projects, such as marine infrastructure and manufacturing. So I'd like to hand over now to Alan and Rod to run through their presentations, please. Thank you.
Thank you, Malcolm. Good afternoon to the guests of this wonderful event. As Mark, as mentioned, I'll speak on why and how we undertook this project. I'll start my presentation by giving you a rundown of the raw water distribution facilities of MWSS and Manila Water. Next slide, please. Yeah, the water system of MWSS, our principal, started way back at the middle of Sierra Madre to Emira River. Then there's a aqueduct that connected it to the Angat Reservoir, and then Angat Dam. Then it goes to a secondary dam called Ipo Dam. And then there are a series of tunnels that would connect Ipo to what we call the Novaliches portal. And from there, a series of aqueducts that convey the raw water to La Mesa. So some would go directly to the La Mesa Treatment Plant, which is being operated by the other concessionaire, Maynilad. And the other, the 40% of the raw water would go to La Mesa and then to Balara. Next slide, please. So from the Mesa Reservoir, there are 3 aqueducts that supply the raw water requirement of our 2 treatment plants there, the Balara 1 and Balara 2. And next slide, please. And as you can see, the why we need to do NBAQ4. As you can see, the 3 aqueducts have actually exceeded their serviceable age. And so there's really a need to replace these old aqueducts, which I will explain further in the next slide. Next slide, please. So here's so the project was conceptualized as part of the Manila Waters and improvement and expansion projects throughout the concession area. Actually, we've already completed the potable distribution side. We've replaced more than 90% of the pipes and the potable side. Now we're focusing our attention to the raw water side. So as I mentioned, there are 3 existing aqueducts that convey water from La Mesa to Balara that were built between 1929 and 1968. That require assessment and rehabilitation. Currently, these aqueducts are being operated in capacity and cannot be shut down, because if we shut down one of them, then the water supply in our concession area would be limited. And so that this project will improve the reliability and security of the raw water transmission from La Mesa to Balara. It will provide a new aqueduct that will now enable sequential temporary service suspension, inspection, rehabilitation, or replacement of these existing aqueducts. Will provide redundancy in case a failure of one or more of these 3 aqueducts, and will allow operational flexibility in the operation of the treatment plant. And then this project is a 7.3 kilometer, 3.1 meter diameter aqueduct from La Mesa to Balara, passing through Andansora, now C5 Avenue, then turning right to Commonwealth Avenue, and then turn right to Viceroy Street in East Fairview, then all the way to La Mesa Dam. So it will also have a new intake and access bridge at La Mesa. And then an outlet portal and downstream distribution work at Balara, wherein that would have, as I mentioned in the objective, that the operational flexibility in the operation of the treatment plant, because there is part of the components of this project is to connect AQ4 to AQ1 and AQ2. So that if we shut down either one or two, then we can transfer the water to Balara Treatment Plant 1. So the project started way back in 2009. The feasibility study was conducted by the joint venture of a local company, EDCOP, and Tonkin and Taylor. Then it was peer-reviewed by another company called Halcro in 2010. But apparently, since from that point up to 2015, there was a reprofiling of our plans. So the project was discontinued and only restarted in 2015, and it was awarded to OBRUP, also our existing PMC, in the construction construction side of the phase of the project, because we wanted to know if if there's a new technology that can be introduced, and if the assumptions in 2009 and 2010 still exist. So it was reviewed by ARUP, and then in 2016, it was the procurement was also awarded to ARUP, and in 2017, the contract was awarded to the joint venture of CMC de Ravenna from Italy, First Balfour from the Philippines, and Chunmo Engineering of Hong Kong. So, of course, in undergoing this project, this is the first tunneling project that Manila Water has undergone. And it also the first tunneling project to be done in an urban area. So basically, the challenge to us then is how to do it the first time, the first time. So as you can see, we have extensive, we spend extensive time in the planning of this project, employing several well-known and consultants who are very experienced in the work. So, and finally, we satisfied ourselves, and as I mentioned, awarded the contract to the joint venture of CFC, which is now called Novabala Joint Venture. Now I turn over the presentation to Rod to discuss the construction side of the project.
Okay. Can you all hear me? First of all, magandang hapon sa inyong lahat. Maayong hapon, salamat siang, buon pomeriggio, buenos dias, and good afternoon to the rest of you. So thank you very much, Sir Alan, for that fantastic introduction and explanation about the history and the concept of the Novaliches Balara Aqueduct 4. As you can see from Alan's explanation, more than 10 years in the thinking and development of the concept, and then handing it over to a contractor to deliver it in a short time, a couple of years. Fantastic. So I'm here today, Rod Scott. I'm the project director for the Novaliches Balara joint venture. As Sir Alan mentioned earlier, we're a joint venture of three major companies. It's CMC Ravenna from Italy. It's First Balfour, a well-known local top construction company, and Chunmo from Hong Kong. And we're a joint venture that successfully negotiated the contract for Manila Water back in late 2017 to deliver this fantastic project. Okay, so we're going to take you through today the description of this project, what it's all about, what we've done, some updates on the progress to date, and generally share with you lots of good information and achievements by this team. So the NBAQ4 project, as we call it, is actually three projects. It's always referred to as a tunnel, which is correct. It's a tunnel 7.3 kilometers in length, but it's also a very, very complex intake structure in the Mesa Lake. And it's a standalone project in its own right. And then we have the actual downstream distribution system, which is a complex arrangement of underground piping and structures to distribute the water after it comes from La Mesa Lake through the tunnel to the Balara Water Treatment Plant, and where it's distributed in various locations around the plant. Next slide, please. So the intake facility is a complex structure at the end of an access bridge in the middle of the La Mesa Reservoir, which is, as Alan described earlier, it's actually a very beautiful location on the northeast side of Manila, which captures all the water from the magnificent Sierra Madre Mountains through the series of dams and ends up here in the reservoir, where we have built an access bridge and a very, very complicated intake cofferdam, temporary cofferdam, which allowed us to build finally the intake structure, and which is actually the receiving pit for the TBM machine at the end of the tunnel. Next slide. Then, of course, we have the tunnel, which all you tunneling guys are all massively interested in. It's the tunnel which will eventually channel all the water from La Mesa to Balara. It's, as Alan mentioned, 7.3 kilometers in length. It travels the majority of its length under the Commonwealth Avenue, and it's generally about 50 meters below ground. Okay. Then, as I mentioned earlier, the downstream distribution system. Here you can see the outlet structure, which is still under construction. This is basically a surge shaft at the end of the tunnel where the water will rise from the tunnel. The tunnel is actually about another 35 meters below the structure. The water will rise vertically to the structure and then be distributed through the complex arrangement of piping, chambers, and such like into the treatment plant. So as I say, it's actually three structures, three projects, all tied into one. Now, going back to the early days of 2017, there was a monumental amount of design work required to develop what was the concept design, which had been developed by Arab initially. And then once we secured the contract with our designer, GHD developed all of the designs for this complex project using the CFD modeling for all the hydraulic analysis from the inlet, the tunnel, and through all of the outlet structures. So after the design had been completed, which took a few years, the tunnel works could only start in the Pagasa area. And in order to start, we had to sink an access shaft. And you can see here a simple schematic of the access shaft with the arrangement and connection to the outlet shaft, which you can see just on the right-hand side of that sketch. And that was built so that we could install all of the equipment in the tunnel and assemble it to then commence the tunneling operation from Pagasa through 7.5 kilometers to La Mesa. Now, the outlet shaft also served as a structure, and the mine tunnel, which allowed basically the decoupling of the tunneling operation and allowed the DNS system to also be constructed separately and in parallel all at the same time. Now, the initial plan at the design stage for the outlet shaft and even in the access shaft was excavation and then traditional bolting and shotcreting. But That method was never workable due to the soil conditions, but eventually the access shaft was sunk using a second pile wall. Next slide. Second pile wall configuration. And here you can see here a general layout of the pile layout that we used. This was basically a 9-meter diameter shaft with 45-meter deep second pile walls, which we used, which was constructed actually by Bauer as our subcontractor successfully back in 2019. And here we see a nice photograph of all these piling rigs from Bauer sinking the second piles for the access shaft in order to allow tunneling works to eventually commence. As mentioned here, as mentioned previously, the access shaft was 9-meter diameter, 45 meters deep, and it took us approximately a month to excavate down from Pagasa down to the invert level of required for the tunnel. Next slide. Okay, so immediately after excavation of the shaft, we then commenced on the excavation of the main tunnel. And the main tunnel was required in order to allow assembly of the tunneling equipment. And you can see here again, the main tunnel where it eventually joins to the outlet shaft. Okay, next slide, please. Here, back in the early days, after the access shaft had been constructed and excavated, we guys conducted traditional 4-pole umbrella and drilling activities to excavate out with traditional method the main tunnel section, which was just under 70 meters in length. Okay. Here, back in the early days, you can see the main tunnel with all the supports and just ready, final excavation and cleaning ready for installation of the rails and ready to receive the tunnel equipment in order to progress with the main tunneling works. And that took approximately 4 months to set all of that up after completion of the access shaft. And now you can see here where we then installed the rails and started installing our equipment, the locos and man carriers for final access to assemble TBM in the main tunnel section and allow it to project through and carry forwards with the main tunnel. Now, here is Dalisai. This is the TBM boring machine that was used to construct the NBAQ4 aqueduct. It's an EPB TBM. We purchased it as early as 2017, long time ago. It was delivered in 2018 through one of the world leaders in tunnel equipment, Herrenknecht of Germany. But this machine was actually constructed and fabricated in China, shipped here, brought to site, assembled in preparation for the early works and the tunnel commencing in 2019. Here's an early picture of the TBM machine. As you can see, this is the main part of the TBM machine. It's about 12 meters long. It weighed in total, including all of the support structure and equipment that runs with it, which reaches close to, just over 110 meters long. And it's an all-up weight of, as you can see here, 266 tons. But this is the main head of the TBM machine, and cuts her head through to the main section and tail skin. Now, our TBM machine, the Dalisai, it's an EPB TBM. It's an earth pressure balance machine. And you can see from the sketch, which tries to give a simple explanation on how that complex machine works. It uses the excavated material in a pressurized environment to balance the pressure of the tunnel face and allow the material, as it's excavated, to be extracted through an auger, through the machine, onto a conveyor belt, and eventually out the back of the machine onto the locomotive and carriage trains, which carry the excavated material out of the tunnel back to the access shaft. Here you can see our TBM when it was being prepared for lifting into the access shaft. And again, the reason for using an EPB TBM was based on the ground conditions here in Manila. And it was the right choice. It was, it's performed fantastically well through the duration of this project. Next slide. So the TBM was eventually launched through the access shaft in January 2020. As you can see here, this is just one section of the machine of 3. And they were all lowered down the access shaft and then reassembled along with all the backup gantries and support equipment, which are close to 110 meters long, in order to proceed with the tunneling operation. Again, here is a sectional view of our TBM. It's actually an articulated TBM, because in this particular tunnel, we had very, very tight bends to navigate in 2 sections of this tunnel, approaching and leaving the underground areas of Commonwealth Avenue. And those tight bends resulted in an 80-meter radius. Therefore, to be able to excavate and turn around those tight bends, the machine basically had to be able to articulate. And that's why you can see here, the machine had 3 main sections and allowed movement for negotiating these tight curves. Now here you go, is a lovely overview of where we are in Manila, from Balara down the bottom at the water treatment plant, Manila Water Treatment Plant. And you can see where we come out under the C5. We turned the tight bend, 80-meter radius, onto the Commonwealth Avenue, and we've travelled all the way up under the Commonwealth Avenue. But not only Commonwealth Avenue, also adjacent to the MRT7. Very, very challenging tunneling works. And you can see at the end, turning off again with a very tight radius, and eventually carrying forward into the Mesa Reservoir. Now, in order to line our tunnel, we had to precast thousands of panels. These were successfully precast in a specialist precast facility by Freefill, and they achieved fantastic results in quality, producing the 2 sizes of panels, the 1.2 meter panels for the straight, slight curved sections of the tunnel. And then we had to reduce to 0.8 meter wide panels for where we had to negotiate and line the tight curves. And all of these panels, as you know, are placed by the TBM machine as it's excavating and cutting the tunnel path. Now, the segment geometry and build sequence was developed specifically with Herrenknecht, the manufacturer of the machine, and also VMT, who are the providers of the guidance system. And they come up with a very, very complex and analytical approach and optimized the panel array, as you can see in these sketches, to give the best finished product for the precast concrete lining of the tunnel. Now, the production rates that we achieved on this tunnel were remarkable. We exceeded the tender expectations by far. And I think that one of the most fantastic achievements about these production rates is that they were achieved entirely through the COVID lockdown period of 2020 and 21. We achieved an average, of 18 rings, which equates to just over 20 meters per day of work, which as I mentioned, exceeded all expectations from what was envisaged at tender stage and moving forward. Okay, next slide. And here we're just sharing with you the actual production rates. And we peaked in 1 month, achieving 600 rings. And you can see we started very, very slowly in January. We were just getting up out of we're just coming out of the shaft. We were producing February, March, getting up to speed. And then COVID came. And unfortunately, COVID brought a lockdown for 2 months. And it created massive challenges and issues, not only for this project, but for all projects and for everybody's life in general in Manila. But we're very proud to share this achievement, and what our tunnel team achieved was fantastic. We had breakdowns, we had issues, but we persevered and we managed to produce these amazing outputs with our TBM machine, and which is all down to various aspects. It's down to correct design, it's down to investing in the correct machine with the correct methodology, and with Kev having the correct people, experienced tunneling crews to produce these results. So we'll move off from the tunneling and we'll move on to one of the other parts of this project, or one of the other projects of this project, and that's the La Mesa intake. Now you can see here, back in 2019, Manila had a massive water shortage, and this is an aerial shot which shows La Mesa Reservoir at that time and the existing intake structures with such low water levels. And I think what's also amazing to share with you is that the La Mesa Reservoir, believe it or not, yeah, it's a catchment area, it's a natural catchment area, but it's also a dam. And on the right-hand side of this aerial shot, where you can see this intake structure, which was built way back in the 60s, that's an earth-filled dam. And that earth-filled dam was built nearly 100 years ago, which is an incredible feat to think 100 years ago that was built. And 100 years later now, we've just built a tunnel into that La Mesa Lake. Remarkable. So here, one of the, again, biggest challenges of this project was getting out into the lake where we could build the intake structure. And the intake structure had to be in the deep section of the lake so that it could operate at all levels of operational levels of the La Mesa Lake. So we had to build an access bridge, and we actually increased the dimensions and structure overall so that we could use it eventually as a construction route to build our intake structure and temporary cofferdam in the lake. Here you can see the access bridge still under construction. And here you can see our construction equipment, our barges and our piling hammers and cranes, where we commenced driving of the cofferdam. And the cofferdam was built as a 20-meter diameter temporary structure in 15 meters of water in order to provide the correct environment for us eventually to be able to build the intake structure and receive the tunnel boring machine. inside the lake. Here you can see the cofferdam after we had constructed it, and it consisted of 56 25-meter long steel casings, which were just, I think, about 950 millimeter casings. And we magically were able to drive all of those piles and sink them into the underlying strata of the lake and close that circular cofferdam. It was a fantastic achievement, and it was done in just under 7 months. And here you can see when we started pumping out to give us the access to the lake bed in order to allow construction of the intake structure. Here, a short video of the excavation process. Once we got to the lake bed, as I mentioned earlier, at 15 meters depth, we had another 4,000 plus cubic meters of material to excavate out of the lake bed into the hard strata below to provide the eventual receiving structure and pit for the tunnel boring machine. Okay, next slide. After excavation of the cofferdam and lake bed, we then constructed this receiving pit, which allowed for the eventual cutting through of the TBM under the lake and into the dry environment of the La Mesa intake structure. And here you can see the successful day inside the La Mesa intake structure when the tunnel boring machine eventually broke through in early August of this year. So that was 18 months after commencement, and basically it was built in just under 16 months. So it was a fantastic achievement, 16 months for the Dallasai TBM to excavate from Balara to La Mesa Reservoir. And we actually achieved that approximately 4 months ahead of the predicted contract schedule, which was without doubt a fantastic achievement. In order to celebrate that achievement, we carried out a virtual ceremony, a virtual breakthrough ceremony, because we were unable to invite all the guests and witness the true breakthrough at the time, due to the onslaught of the ECQ and restrictions in place. But the virtual ceremony was very successful. We had hundreds of people online, and here you can see a lot of the pretty faces who joined in on that show. After the event, Manila Water proudly announced the facts, the results, and the success of what, without a doubt, for Manila Water was the closure of a 10-12-year plan and a massive risk and a massive cost. And there was a lot of relief when we managed to achieve a breakthrough of the tunnel in early August last year. It was the succession of all of the thought process and ideas and dreams of Manila Water, and this was the fruition of all those hard work and dreams of all of those senior people in Manila Water from years ago. After completion of the breakthrough and TBM machine arriving in our cofferdam, we then had to obviously dismantle the TBM. That was a complex task also, because this machine really wasn't built to be dismantled. It was built and assembled in major sections to be put together in a very, very simple way at the beginning. But the actual thought process of dismantling it took a lot of thinking out and working out, and very tricky, heavy lifts, because all of this has to be done in the marine environment, stripping the machine part by part, And here you can see the cutter head, and the cutter head alone was a 20-ton piece of machinery, which had to be lifted out from the crane on the barge, lifted to another barge, and then dispatched to the shore for eventual travel back to Balara, where we are now currently actually reassembling the machine for its next challenge in life. Here you can see the final sections of the machine being dismantled and ready for lifting out. And we've just achieved that over the last few weeks. It's a fantastic result again, successfully removed, and we're now hard at work building the intake structure from this pit above in the depths of the La Mesa Lake. So we'll step back now from the tunnel and the La Mesa Reservoir, and we want to discuss another tunneling aspect of the NBAQ4 project, where in the downstream distribution network system, where we have kilometres of pipes to lay at great depths, 10, 12 metres below ground, and there were sections that were impossible to be excavated. And the eventual solution was to come up with a traditional 50-metre mine tunnel between two areas of the downstream distribution network. And this was also done very successfully with our team using traditional mine tunnel methods. We obviously created the open pit access shaft area here. We did traditional drilling and excavation by machine, and achieved good productivity in a safe and successful manner over this 50-metre mine tunnel excavation. So we actually constructed the tunnel from two sides. We commenced from the west side and excavated about 45 metres of the tunnel. And we did that in order to get ahead, because at the other end of the tunnel, we still had a major area of excavation. So we took advantage of pushing ahead and putting 45 metres of the tunnel through in order to allow us when we did complete the excavation at the AQ2 side for the major pipeline structures and connection areas, we were then able to break through the last 5 metres of tunnel and connect the tunnel up between this 50-metre section. Now that took us about 3.5 months, and again was a great achievement, and all achieved in a very, very safe and successful manner. Approximately 12 metres, 15 metres below the overlying structures and ground. So that's basically an explanation of what's been done to date. The tunnel is now complete, and it's going through the dismantling of all the utilities and pulling out all of the equipment and final inspections while we construct the second part of the project, the La Mesa project. That will be complete by the end of this year. And then we have obviously the downstream distribution system of pipework, as you can see here, the outlet structure, the dissipation pit, all adjacent to the existing water treatment plant. Now, this photograph doesn't really do justice to the depth of these pipes. These pipes that you can see partly backfilled are generally 8 to 10 metres below ground in very, very complex arrangement in the Balara water treatment plant, because what we had to do there is provide open excavation under all of the existing live utilities. Now, the existing utilities that are in place are aqueducts that are supplying water from La Mesa that were built, in some cases, 70 years ago. You can see here in this aerial shot, again, the new pipework that's being installed in these open excavated trenches under existing utilities, which are, in some cases, 60, 70 years old. And we've had to put in place massive temporary structural steelwork supports in order to support all of these utilities. And like all projects, a lot of these utilities were unknown, which created additional challenges and interest for the project. Again, here you can see some of the structures. And this is actually the end of the main tunnel section. The main tunnel section actually is on underneath the ground on the right-hand side of the structure, to the right of that major structure there. And yeah, so once we complete the network of downstream distribution, we have to connect these structures into the existing live waterways that are providing Metro Manila's water supply, because we can't turn it off. So these are some of the challenges that we face. We've got 3 live connections to construct. We've got a very, very complex temporary works arrangement designed that we will insert and construct inside the live pits, which are running, as I say, at full capacity with water, because we can't turn the water supply off to Manila. And we will break through into the existing structures in a live condition to eventually allow the connection of La Mesa and the NBAQ4 pipework system to supply water into the Balara Treatment Plant. So back to our intake structure. The TBM has now been removed, and here we're just doing the final cleaning out and ready to start the first construction lifts, concrete rebar, traditional walls, circular shaft, which will also contain the access gates to control the water flow in and out of this system. And eventually, this magnificent structural steel cofferdam that we took 7 months to build will eventually be removed, and a concrete intake structure will be left in the La Mesa Lake. Now, the next stage of our project at the moment is now the complex electromechanical installation. So all of this magnificent civil work, tunneling work, marine work is basically coming to an end by the end of this year. And in the coming months, we will commence all the complex installation of the valves, flow meters, and control systems that will eventually give Manila Water the ability to monitor and operate the intake of water at La Mesa, and then automatically control all of the valves and distribution of water through the 3 AQ connections to the Balara Treatment Plant. All of that complex, expensive electromechanical equipment is now being shipped from all over the world, again through another very complex procurement, well, first of all, design, approval, and procurement process. And now we're at the stage of bringing all these materials in from all over the world, from America, from predominantly China, Germany, Belgium, all over the place. And all of that equipment is well, some of it's here, and a lot of it is now arriving, ready for the complex E&M installation, which we will carry out over the coming 2 or 3 months, and moving on to the final test and commissioning phase of this project in the first quarter and mid of second quarter of next year. So that's basically a summary of the NBAQ4 project, what's been achieved to date, where we are and where we're going. We've achieved that with utilization of close to 3 million man-hours of work by our team. It's a fantastic achievement. It's very, very challenging and interesting project, and been achieved under challenging and interesting circumstances, and all through the last stage of this project, anyway, the last year and a half under this COVID pandemic. Okay. So just in closing, like all magnificent projects that we're all involved in, and I'm sure all of the guests here today have been involved in some magnificent projects, tunneling projects, building projects, infrastructure projects. And one of the projects also that we are coming to close on recently with our partners, Acciona and DMCI, is the Cebu link, the third Cebu link bridge. Now, everybody who's been involved in projects like that, they're without doubt iconic, wonderful masterpieces of engineering that are there to be seen and treasured for all those who build them and all those who just like seeing fantastic engineering projects. And they're there to be seen forever. And I'm sure if you look on Facebook and social media just now, you'll see lots of magnificent photographs and pictures of the Cebu Link Bridge at night time and daytime. It's an absolute magnificent bridge, and it's a magnificent engineering achievement. But what I would just say in closing is that the NBAQ4 tunnel project has been a magnificent engineering achievement, constructed under very, very difficult circumstances. But at the end of the day, the only thing you will see is a small intake structure in the middle of La Mesa Lake, because all the magnificent hard work and effort that's gone into it is all hidden below ground. And also that everyone can take for granted when they turn on their water supply, they've got never-ending supply of water. So let's move on and close on what's been achieved. And we've tried to share with you a lot of the interesting aspects of this project. We can't cover all of it. We can't share all of it, but we hope that you found it very interesting. And we're also willing to take a few questions or provide further information for anyone who's at all interested to learn and understand more of this magnificent project, the NBAQ4 Tunnel and Infrastructure Project. Thank you.
Okay, great. Thanks, Rod. Thanks, Alan, for that fantastic presentation. I think we're at 6 o'clock already, so you're bang on time. But I think we can take some questions from the audience and from those that have been posted. So I think there's a common theme with some of these questions about some of the challenges that you've had. So I think one of the questions that was posted on the when people were registering was there's a couple of questions that had the same sort of theme about the challenges. So top 3 major challenges, how did you address them, and what are the 3 top risks and mitigation measures that you had? And maybe perspective from the client side, Alan, and maybe from the contractor side, Rod. So how do you answer that question?
Yeah, probably I'll start, Mark, on the client side. As I mentioned in my initial presentation, one of the challenges basically for Manila Water in undergoing this project is it's new. It's new to us. It's new to actually it's new to the country. It's a tunneling project in the metropolis. So the basic challenge to us is how to do it and who will do it. So those are the questions that were in my minds before. So in order to eliminate those challenges, as you can see in the presentation. We spend a lot of time in the planning stage. We've hired expert consultants that would help and guide us in this one. And finally, and also to entice, we're not also sure if if we can bring in contractors to this project. So as you know, Mark, what we did is your team has done is to invite all known contractors, suppliers in one meeting, like we called it the Industry Day. And then we presented this project. And probably the turnaround that for these contractors to participate in this project is we focus more on the technical aspect of the project. We don't want this project to be a price war, so we shifted more on the technical side. So it's 80-20, 80% technical, 20% financial. And ARUP has developed a selection criteria which is fair and understood by everybody. So I think that that's the key. That entice all these guys to form their joint venture and participate, and that solve the problem. And probably the planning and then all the meticulous planning of this project has helped. I think it's helped the contractor to develop a very robust and intelligent bid and their design. So there we go. So the project has been a success right now.
Yeah, I think you're right, Alan. You know, it's managing all the risks through the whole process and trying to avoid and mitigate as soon as you can. So yeah, I think it's a collaborative process from the start. So Rod, what do you think? What's your sort of three top?
Okay. Well, as everybody
challenges?
knows, being a contractor is every day is a challenge, and we have the joint venture challenges, we have the personal challenges, which are never ending on a project like this. I wasn't here in the early stages of this project, but you know, the challenges that were faced and risks in the early days were huge. It was a new joint venture. It was a joint venture between three companies that actually didn't know themselves or hadn't worked together before, but they put together a very successful bid with as a complete team with an experienced designer. And I think the real key to the success in the early stages of this project was, as Alan mentioned, the close planning and detailed development. You know, ARUP put forward and conducted, you know, very, very detailed concept designs. Manila Water spent years thoroughly researching and thinking how they were going to do this job. And as a contractor, once we were on board, as I say, I wasn't here in the early days. I was here in the latter days of this project. But without a doubt, the success of this project stems from also our, excuse me, the investment in the proper equipment. You know, we, sorry, we get some rogue phones here on the table. There's people just trying to disturb me in the middle of my speech, but that's okay. We're used to that. Sorry. So, yeah, the reality is that the joint venture invested a massive amount of money in this project. It was without a doubt, you know, a very, very high level project for all of the companies involved. And the investment in the right equipment with partners such as Herrenknecht, with using experienced and knowledgeable designers such as GHD and Poiri, and investing also in the right people. the right people is always the key to success in any projects like this. And yeah, in the early days, this project went through quite a lot of changes in management and people during the early challenging days. But I think, without a doubt, the investment, the massive investment in equipment, the right engineering, the right designs, the right people, allowed for the tunneling operation to proceed. Now, once the tunneling operation was going, it was a production cycle. You know, it was, and it's like all these things in the construction environment. If you put together the right equipment, the right methodology, the right thought process, the managing of it afterwards is definitely much easier. But that's only one aspect of the challenges in this project. I think one of the biggest challenges, personally, for me, was just driving up and down the C5 every day to get here. But that's another challenge for another day. I think the La Mesa intake structure was, without a doubt, one of the biggest challenges, because it went through various engineering development stages and temporary works, thought processes in the early days, to eventually what we have. And there were certain delays in the beginning. And, you know, we had, like all contractors face, we have challenges with ground conditions, we have challenges with the weather, we have challenges with the suppliers, challenges with the subcontractors. But for the La Mesa intake, I think we persevered there and we pulled together what was, at that stage, maybe a bit of a disjointed situation, and we turned it into success. But we also, after completing, which I felt was a monumental task of building that cofferdam in the middle of the lake and excavating out, you know, 30 meters down in the middle of that lake. And when we were nearly at the bottom, we had a massive inflow of water. And we had an inflow of water through, you know, an unknown source of void in the ground, in the lake bed, that undermined one of our socket piles. And we had a challenge on our hands. But like in all cases, we rose to the challenge, we dealt with it. We got it closed out. We did it without any, fortunately, without any accidents or injuries. We did have some damage to some equipment, but we surmounted that problem. And I think that is, without a doubt, for me, was a massive challenge. And yeah.
I think, Rod, there's also, you can safely say that COVID has been a big challenge as well, you know.
Exactly.
And you know, and it's delivery of things, it's supply of concrete.
Yeah.
You know, all of those sort of things have been a bit of a challenge, and must be one of the overriding things that, you know, I think it's been managed quite well, to be honest, but there's certainly some significant problems there.
Yes, no, correct. That was actually one of my other challenges. The COVID was something that we all know now. Nobody knew about it before. When it hit us in March last year, it was such a surprise situation. We all thought it would last for a couple of weeks. It dragged on for a couple of months. But like in all challenges, we react to the challenge and we deal with it, and we put in place measures and control measures to manage it. And we've done that successfully here. And we've had our ups and downs of infection rates with COVID. We've dealt with it successfully. And now, you know, even today, actually, I just had my second vaccination today. So we're now 100% vaccinated here at the NBAQ4. And I think now it's good, and the positive news in the local environment is that we're hopefully getting through it. We're not through it yet, but some of the challenges that it created on this project, for example, all of the workers, we had to house all of the workers in accommodation. We have to take care of them. We have to feed them. We have to transport them. We have to take care of their welfare. These are all issues that nobody ever foresaw in the early days. But yeah, we've dealt with it, just like also, you know, all of the contractors in Manila have had to deal with it, and some people have had monumental challenges with it. Certainly we had our challenges here, but I'm proud to say we dealt with it, and we continue to deal with it and manage it in a successful way. Yeah.
So, you know, there's some other questions here. So I think we'll have a few more. There's a question here about hyperbaric conditions and, you know, what are the regulations in the Philippines? So, you know, I know the TBM was set up for, pressure, air, compressed air. So, you know, what was the challenges with that? Did you use it? Or,
okay. Okay, right. So I'm not aware of any actual regulations here in the Philippines, but traditionally in all these tunnel projects, people use the British Standard Guide for the Bible of Tunneling Operations, which has its own chapter on the compressed air use. The BS 6164 details all the requirements for working compressed air. Now, as you correctly mentioned, our machine, it's a top of the range machine built by Herrenknecht. Okay, built in China, but it's built under their strict regimes. It was built with the chamber on board to allow interventions at the cutter head. Fortunately, we never had to use that, but we managed that. Now, what we did is we tied up a consultancy agreement with one of the local specialist hyperbaric diving doctors, I'll remember his name. I've got it in my book somewhere actually. But anyway, we tied up a consultancy arrangement with them to do all the training, basically in line with diving principles and such like for control of hyperbaric conditions. But what we did was, when we had to do any work on the cutter tools of the TBM or whatever, we managed that and did that in timing when we knew we had low water pressures and low water conditions in the tunnel. So we managed that so that we didn't have to ever get into that position of using the hyperbaric chambers and having people working in the compressed air environment. And yeah, fortunately that all worked out, and there you go.
Okay. Okay. Thanks, Rod. So some of the other questions there about some of the community consultation. Obviously the project running close to or near some communities. So there's a question about prior consent and consultation being done, Alan. I know that the Manila Water team's been had done quite a lot of that at the beginning. So maybe you can just run through what was done at the start, and I know the contractor's been involved in discussing things and interfaces with other projects as well.
Yeah. You mean this project, this project when the contractors started this project, Mark?
Yeah. So the question is about the consultation process, right?
Yeah.
At the start.
Yeah, at the start, what we did is to have the contractors, aside from that industry day where we introduced the project, we also during tender we did not only distributed the bid docs and then wait for them to to submit the bid. What we've done, as you all know, Mark, is we during the conduct of the tender by the way, we really gave the contractors ample time to develop their bids, because we wanted to have the contractors to submit an intelligent and robust bid for that. And then in the course of the tender, we conducted 2 mid-tender reviews. I remember a month after they received the bid documents, we conduct the first mid-tender review, and then in that review, we entertain queries and everything, and then try to resolve whatever queries or things that need to be clarified. Of course, in the first month of the bidding, you won't expect the technical side of the tender. It's more on the contractual financial side. So that's it. So once we've done that mid-tender review, then everybody we're in line. We make sure that we are aligned. Our understanding is aligned with the understanding of the contractors. So with that first meeting, we finalized the contract, basically. So the contract, this is the phase of the final phase of the contract. Then they move on, and be about 1.5 or a month before the end of the submission, we conducted the technical review. Then we in the same thing that was done. Are we aligned? Do we have the same understanding of what we wanted to achieve in this project? And then based on that, we've also accepted queries and then clarifications, and then finalize the technical side of the submission. And because of those engagement, I think we've received very robust and intelligent bids from the contractor. And as what Rhoda mentioned, when it was awarded to them, it's quite now easy for them to develop the design, because even during the tender, we are in unison on what and the same understanding on what we wanted to achieve in the end. So that really helps a lot in developing this project. The constant communication with the participants, even during the tender stage.
Yeah, well, I think the question also goes to, were people aware that, we were tunneling down Commonwealth Avenue, and basically I think nobody was really aware of all of that, Rod, to be honest. People had been consulted, but actually there was no disruption, or people just didn't know that we were tunneling, okay, 50 odd meters or so below the road, but, it wasn't really any inconvenience to anybody.
Yeah, I think that's in general correct. I mean, really the only major challenge I think faced with that was with San Miguel and EEI on the MRT7. When it came to the close, we had the close proximity, very, very close to MRT7. Then we did a lot of consultation then with all partners, with all parties, Mineral Water and ARA themselves. We were all involved in close communication to ensure safe pass by of the tunnel.
Yeah. It was almost 2 meters sort of clearance from the piles of the
Yeah, correct. Just actually, it's amazing to think. Yeah, one of the piles that supports that MRT7, our tunnel is just over 1 meter away from it. So it's testament to actually what's been achieved from the design. From the control of the alignment of the tunnel, it's quite amazing.
Yeah, and no recorded impact or any problems with it.
That's correct.
Yeah. So and I think overall there really wasn't much recorded settlement or defamation or anything. I know there was some water issues. So one of the questions here about what were the geological challenges encountered during the excavation. So, you know, there was some sections of water inflow that you've been able to handle. So any other things you want to say about that, Rod, in terms of geological challenges encountered?
Yeah, I mean, we're fortunate in that the majority of the ground conditions for the tunnel were pretty consistent, apart from obviously the water levels. The water levels were varying, and they created some challenges at times. One of the operational issues with the TBM is obviously the tail skin brushes, and the maintenance and replacing of those on a regular basis did become a topic of discussion. But it was eventually handled, and we managed it. The guys managed it very well. And we did changing of the brushes again when we had dry conditions. It wasn't possible to do it when we had wet conditions. It was, and our team managed that. We've done it. The results there. Where we did face, I think, challenges with the ground conditions is La Mesa. We had some challenges, obviously, with underground conditions of the lake bed, with the piling and doing that. But again, we've dealt with that through the engineering phase and the construction phase, and we have to adjust and modify to suit the ground conditions that we face. La Mesa was a challenge, but the DNS also. The DNS, fairly consistent, similar ground conditions. They had adobe material and a lot of it, but as you know, the utilities and existing services are the things that were the challenge there more than the actual ground conditions. Yeah.
Okay. So, yeah, okay, there's another question here about, is there any future Manila water projects similar to Novabala? So, I don't know, Alan, I can get T5 is one that may be coming up soon, and that's a combined one with Manilad. So, do you want to mention that at all?
Yeah, actually, there would be more tunneling, more in the future. Yeah, we mentioned T5. It's being it's being done in partnership with Manilad. So it's on tender at the moment. As for Manila Water, we have other tunneling works that would be done. Actually, I think this project is open, probably open the gate for us, open our eyes that, yeah, it can be done. Actually, this morning we're just meeting for a actually much longer line. So the feasibility study, hopefully it can be awarded. It would start within the month. Then if the FS turns out to be positive, then we'll do that. It's triple the length of this project. So it's exciting. Yeah, it's actually before we are not even thinking of this kind of work. But when we saw the advantage of doing tunneling work, as you mentioned a while ago, there's no disruption. And then even when we did the consultation with the local LGUs, even the communities, it's more easier to get their the permits and everything, because traffic is a big issue in Manila. So yes, there would be more tunneling projects that are on the pipeline. Even the other side, because I knew some guys in the other side in Manila. They're also developing new one for their new project.
Yeah, good. Well, that's good news. I think that this is a a good forum to tell people that there's more tunnels coming. So I think that's good news for everybody. So thanks for that, Alan. Maybe just one last question. I think this is really about the sort of sustainability of some aspects about recycling the excavated material. I know, Rod, it was going to a designated area. but you know, the material that came out of the TBM, you know, from the excavation, you know, can you just explain what was happening to that?
Yeah, okay. Well, the bulk of the material that was removed from the tunnel was used for landfill in areas outside of the city. But the issue with the excavated material from the tunnel is because it's coming out in such a wet condition, it takes a long time to dry it out. So we had, you know, we had a large area of the gas site sanctioned as the processing area for that material, and then removing it from site. But what we've done in the other areas, for example, DNS, you know, the DNS has involved massive excavation, open excavation to 10, 12 meters. And that material we stockpile and we reprocess and use for backfill. And, you know, that's the right thing to do.
Yeah.
Also in at La Mesa Reservoir, the material that we have removed from the lake bed, we have brought it to the shore, we store it, we allow it to dry, we reprocess that in order to allow us to use that material, because we have to backfill eventually inside the cofferdam around the intake. And we've also got, you know, other structures. So in principle, we reuse as much as we possibly can. You know, it's not only environmentally the right thing to do, sustainability-wise, but cost-wise, it's also the right thing to do. Yeah. Yeah.
No, I agree. Well, I think we're sort of running out of time. That's half an hour beyond our designated time. Okay. So thanks both Alan and Rod for your presentations and the feedback in this panel session. So great, thanks for telling us all about the NBAQ4 project. So I want to just sort of close by saying thank you for that. Just as some reminders to everybody, you know, we've started this newsletter, and we're really looking for you guys to tell us some of the news bites that you have of your projects and the things that are going on in terms of tunneling. We're also looking at preparing a register of tunnels and major underground structures in the Philippines, and we're going to post that on the website. So that will hopefully be a live document, and then as people can give us more information about the tunnels that they're working on and future tunnels, that can be updated, and we have a register that can be used by and useful for referencing. We're also going to update the website soon. As Malcolm mentioned earlier, please join the society and contribute to the tunneling community. There is another presentation on November, so we currently don't have a speaker for that. So with so many projects going on just now, and Metro Manila Subway, come on guys, you know, there's a few consultants, a few people out there I'm sure are dying to give us a presentation. So you know, I hope that you'll volunteer or come forward for that presentation in November. So thanks everybody for your contributions, and thanks again to Alan and Rod for their presentation tonight. I think I'll hand over to Lance, who wants to do a picture taking. Is that right, Lance?
Hi, Mark. Yep. Yeah. So, hi everyone. You should be seeing a prompt on your screen soon to open your camera for our group photo. So while we wait for everyone to get ready and join in as a panelist, let's just wait a few more seconds.
I just have to say there's some other questions that are on there. We'll try to answer them and put them in the website. So you can.
Yeah, I think if people, you know, people can send questions and we can deal with them over any time. But I think just in closing, Mark, I'd just like to say a few words that I would say that the NBAQ4 project is a fantastic example of how things should work. I'm saying this from a contractor's point of view. I think it's a fantastic example of teamwork from Manila Water, the leadership with Alan, through yourselves, Arab, and through the various guys who've led it, from James and Andy, and you know, our joint venture, the leadership and guidance and support from our partners. But also all of the subcontractors that we chose to support this project, such as Bauer and Luz Verminda, and, you know, and suppliers, which, you know, we've had so many, and we definitely strive to choose the best. And I think this project is a very good example of when everybody is working together, we have the right mindset, it works. And I think it's also a fantastic environment for a lot of the young engineers who have found fantastic experience at a young age in these projects, such as, you know, the NBAQ4 tunnel. And successful job, it's all about the people, yeah. And we got some great guys in this team, and they've worked very, very hard to deliver this job for Manila Water, and we're all very proud of it. And we're very open to answer any questions or queries or whatever. So yeah, thank you.
Okay. All right. Thanks, Rod. Thank you.
Salamat po.
Yeah. Okay. So Lance, are you ready for your picture taking? So everybody, please, your cameras on, so we can see you guys and have a show. There's 62 of us here, so come on, we need a few more than that. Come on, guys.
62.
Well, there was 90 at one time.
Who's 62?
Hi, Mark. So actually just checking the attendees, we have around 20 plus still, I think, not willing to show their cameras, but yeah, since it's already 6:30, I think we can take this time to just start with the group photo.
Okay.
So there's gonna be a few pages. So everyone, don't please hold your smiles. Okay. All right. Let's take a few more. 1, 2, 3. Again, please hold your smiles. And last one. And there. Okay, I think we have it.
I recognize a few faces on there.
Yeah.
Hey guys.
Great, thanks, Lance. So hi everyone, and hope to see you again next month. And you know, please look at the website and contribute to the Tunnel Society. Thank you, guys. Okay.
Okay, thank you.
All right. Bye.
Bye.